Welcome to the Crazy Hat Chemist. So today we are doing another video, another lesson on thermochemistry. So let's get moving. Bam! Today we're going to be doing a thermochemistry calculation number 1. So the question states the following. How much energy in kilojoules are lost as the temperature of a 25-gram sample of aluminum changes from 85 degrees Celsius to 24.3 degrees Celsius? So the first thing that we need to do is figure out what mathematical equation we're using, and that was discussed in a previous lesson. So this is the equation. So it's Q equals M times Cp times delta T, and delta T I've replaced with Tf minus Ti. So now I'm going to figure out what these numbers are and where they go within this problem here. So what am I solving for? I am solving for Q, which is how much energy, how much heat, okay, and it's going to be lost, okay, and then I am going to plug in the values that I know. So that mass is 25 grams. So that 25 grams, the grams lets me know it's a mass. It's the mass of the aluminum, so that's really important. The aluminum tells me what the specific heat is. So you need to review a previous lecture here and then look at the specific heats of various different substances, and in that video was the specific heat for aluminum. So it's not given in the problem, it's typically given within the problem if it were a written out problem, or in the back of the textbook, or within the chapter. Okay? But we do know the temperatures, and we've got to figure out what these temperatures are. It changes from 85 to 24. So the from 85, that's our initial temperature, to 24 is the ending final temperature, and so that's what goes right there. So now I'm going to plug in these numbers, including the specific heat capacity for aluminum and the specific units. Okay, so the 25 grams is in there, the 0.902 joules per gram degree Celsius specific heat for aluminum is replaced in there, and then the 24.3 minus the 85.0. Okay, I've placed that in there. Notice that I've included the units. It's essential that you use units every time you use a math problem. Because what are you trying to do? You're trying to cancel out the units. I did mention this already. This is the specific heat capacity for aluminum. That was in a previous lesson. You are crossing out the units of grams. You're also crossing out the units of degrees Celsius. Before you do this in your calculator, you're going to make sure, are the units that I have right now that are not canceled out, do they correlate with what I'm solving for? What am I solving for? I'm solving for Q. Q needs to be in a heat term. That is calories, joules, kilojoules, something like that. And the only units that do not cancel out are joules. And I am solving for Q. So this should make sense in that now you can do the math and plug in the numbers in your calculator. Okay? So plug in those numbers into your calculator and you're going to get negative 1,368.785. There's probably some more decimal values after that. Okay, and now I'm going to reread the question and say, what is the question asking for? It says, how much energy in kilojoules? Well, my answer right now here is in joules. So I need to convert these joules into kilojoules. So this is the conversion from joules to kilojoules. So this is an infinite number of significant figures for the 1 kilojoule and the 1,000 joules, because this is a definition. Okay, and now this is the number that I get, negative 1.37 kilojoules. I have it in the correct number of significant figures from the original numbers that were in the problem. The original numbers that were in the problem were the 25.0, the 85.0, the 24.3. Okay, and so this is a negative value because it's lost. It's energy that is lost. Okay, hopefully that makes sense. Okay, all right. That was another great video here. Hopefully you enjoyed that. And today I think I'm wearing either a starfish or an octopus. It does have 8 legs, but it kind of looks like a starfish. If you like that video, give me a thumbs up, please. And please subscribe to my YouTube channel. I greatly appreciate that. Have a great day.